So, hi everyone. Welcome to the next video in the series of Verilog. So today we are going to discuss, in the last two classes we have discussed about the packed array and the unpacked array. So today our discussion will be on the mixture of this packed and the unpacked array, which we are going to call it as the multi-dimensional array. So whenever we call the multi-dimensional array, we are going to consider it as an combination of packed array plus unpacked array. So just let's try to figure out the differences between the packed array and unpacked array, which will be really helpful for us in figuring out the next things. So generally a packed array will be in the form of reg 3 down to 0. Let us consider A for now. So the compiler will assume this one like in a packed way. So this will be 3, 2, 1 and 0. So whenever I'm assuming an unpacked array, the compiler will assume in this way. So, so let us consider this one as the reg A 3 down to 0. So 1, 2, 3, 4. Because of the 3 here, 3, 2, 1 and 0. Okay. Now, whenever I'm considering and packed and the unpacked array together, obviously, what should be the Verilog idea for a multidimensional array will be in terms of reg. So as of now, let us consider 3 down to 0 array of 3 down to 0. Is that okay? So now let us assume how the compiler will analyze it. So whenever we are having a multi-dimensional array, the first step which we need to understand is we need to assume the unpacked dimensions first. We need to assume the unpacked dimensions first. So this will be the unpacked dimension and this will be the packed dimension. So whenever we wanted to assume the unpacked dimensions, here there are 4 dimensions possible. So let me assume an 4 dimension. So as the unpacked dimension will be divided like this, so let us divide this in terms of the 4. So this will be going to be 3, 2, 1 and 0. Now each unpacked dimension is divided into 4 packed dimensions. So 1, 2, 3 and 4. So this will be 3, 2, 1, 0. So this is how the compiler assumes an packed and the unpacked array. So if we can see this, so as we have discussed, the first one which we need to consider is the unpacked dimension and the second will be the packed dimension. So this particular side is showing us the unpacked dimension and this side is showing us the packed dimension. Okay. So whenever I'm assuming this packed and unpacked dimensions, so if at all, if I want to know what is the, if I wanted to print or if I wanted to access this memory location, first I'm going to write the unpacked dimension followed with the packed dimension. So 3 comma 0 will be this one. So this one will be 3 comma 1. This one will be 3 comma 2. This one will be 3 comma 3. This one will be 3 comma, sorry. 2 comma 3. This one will be 1 comma 3. This one will be 0 comma 3. This one will be 2 comma 2. This one will be 1 comma 2. This one will be 0 comma 2. This one will be 2 comma 1. This one will be 1 comma 1. This one will be 0 comma 1. This one will be 2 comma 0. 2, sorry, 1 comma 0 and 0 comma 0. Okay. So this is how a compiler will assume. So see here, the first element will always represent the unpacked dimension. Unpacked dimension. So the second element will always represent the packed dimension. To have the understanding of this, let us go with a very simple code. Let us write down a simple code in order to analyze. So as we have already discussed, as of now we are just working on the examples, so it's better to write the code inside this test bench. So let me consider a module. Module test underscore multi-dimensional array, end module. So once we defined the module, so let us define a multi-dimensional array. So every time it's very tough for me to define the packed dimensions and unpacked dimensions. So let us consider it as parameter packed dimension. Packed dimension is equals to, let us consider 4. Next, let us also assume, sorry, let us also assume the unpacked dimension, and let me also consider it as 4. So now here, whenever I'm describing an array, a multi-dimensional array, let us take this packed dimension -1 down to 0, and this will be the array of, again, the unpacked dimension. This is what we have assumed in the example, right? So I'm taking the same thing. Okay. So now let me take initial, begin, end. Okay. So let us assume array here, as we are already sure that we are having only 4 values. Let us assume array of 0 is equals to 10. Array of 1 is equals to 11. Array of 2 is equals to 12. Array of 3 is equals to 13. So let us assume this particular conditions. Now in the previous session, I think I have explained how to describe, or if you want, if you are having all the multi-dimensional arrays, how to print them. So let us take the dollar display of percentage p comma array. So let us wait for the result. So I hope there are no compilation issues, but let us check. Yes, the compilation is clean, and see here we can see that it is in the form of 13, 12, 11 and 10, which is almost in the similar way which we have given here. It is in the form of 13 comma 12 comma 11 comma 10. Okay, but if I want to display every dimension and every value, how can I display it? So for suppose my understanding is I want to display, yes, So here it is in the 3 down to 0. So this is going to be 3, 2, 1, 0. And here also it is going to be 3, 2, 1, 0. So array of 3 is 13. 13 is nothing but 1, 1, 0, 1. Array of 2 is 12, 1, 1, 0, 0. And array of 1 is 11, 1, 0, 1, 1. Array of 0 is 10, 1, 0, 1, 0. Okay. So this is how we are going to consider. So now I wanted to print each and every bit. Okay, its dimension and each and every bit. So in order for that, let me just take the reference of this code. Let me write a simple code which should be common for all the possible conditions. So let me take a for loop. So whenever I wanted to declare a for loop, I want an integer I comma j. I'm assuming two integers because there are two things, two packed and unpacked dimensions. So let me take for I is equals to 0, I less than, let me initially see the first loop which needs to rotate is nothing but the unpacked dimension. So once it goes into the unpacked dimension, it should go into the packed dimension. Like for suppose I wanted to print the values of the complete unpacked dimension first. Later I need to print the values of the packed dimension. So for suppose I wanted to start from here, later this value, this value, this value. Next it should go to this value. So this is how it should get printed. So first I need to choose the unpacked dimension. So I'm choosing something like I is less than unpacked dimension. Is that okay? And Verilog doesn't support I++. It's system Verilog which supports it. As we are writing in the Verilog, I am writing it. So begin and the end. So inside the for loop, I'm going to compare it with j equals to 0, j less than packed dimension, and j equals to j plus 1, begin and the end. Okay. So here I'm going to consider this one like dollar display a of percentage 0d and percentage 0d. So a small mistake which I am doing here is equals to, here it has to be array. It's not a. Array is equals to percentage b. B for binary, 0d for decimal. So first I wanted to use I comma j comma a of I of j. So this is how you are going to represent an or call an multi. If you want to read a few bits inside the multi-dimensional array, this is how we are going to mention. Okay. So I think everything is clean, compile clean. So let us run the code. No, it's not compile clean. Why? Undeclared identifier a. Yes, I made the same mistake like earlier. So this has to be the array. So if we are running this, see here, it is 0, 1, 0, 1. Okay. So the value of the 10 is nothing but 0, 1, 0, 1. Yes, I got 0, 1, 0, 1. Next, the value of this one is 1, 0, 1, 1. Yes. The value of this one is 1, 1, 0, 0. Yes. The value of 3, the unpacked dimension 3 is 1, 1, 0, 1. So yes, everything is right.